Hey guys, this time we're taking a look at moles. All a mole is in chemistry is a way of counting particles. Since atoms are so small, it doesn't really make sense to count them in pairs or dozens or anything like that. But just like 1 dozen equals 12 of something, this mole also equals something. And if we're counting, 1 mole is equal to 6.02 times 10 to the 23rd of something. Okay, that's a huge number, and the reason why we need a number so large is because these atoms are so tiny. I have this many things in just a small amount of matter. Okay, we can also use a couple other equivalencies. 1 mole is also equal to 22.4 liters of anything. Okay, any gas that is at STP, standard temperature and pressure, takes up 22.4 liters of space. Okay. Also, I can take a look at mass and say that 1 mole is equal to the mass on the periodic table. Okay. For example, here I have a couple squares. I see these masses in AMUs at the bottom of the square. If I had 1 mole of iron atoms, I would have 55.845 grams of iron. So you can imagine taking a scale and weighing out 55.845 grams. If I did that, I would have 6.02 times 10 to the 23rd iron atoms. Okay. Oxygen is a smaller atom. There's only 8 protons in oxygen versus the 26 in iron. So all I would need to have 1 mole, or 6.02 times 10 to the 23rd oxygen atoms, would be to have 15.9994 grams of it. Okay, so we can see that there are several different ways to express a mole. And we can use these conversion factors right here to express a quantity of something a little bit differently to suit our needs. So the key to solving these word problems is always use what they give you. It's usually going to be a number, and convert using these conversion factors until you get the quantity that the problem is asking you to find. Okay. This first problem, how many moles? That is what the problem is asking us to figure out. So we'll know that our problem is done whenever our unit is moles of magnesium. Okay. The number 3.01 times 10 to the 22nd, that is the number that is given to us. So that means we start our problem with 3.01 times 10 to the 22nd atoms of magnesium. Okay. And these are dimensional analysis problems, so we set up our railroad tracks. Okay. The key to this is whatever unit I have on the top of one of these, I must have that exact same unit at the bottom diagonally. So since I began my problem with atoms of magnesium, my first step has to have atoms of magnesium at the bottom. And the opposite of that is 1 mole. Every step will have 1 mole in it. So I'm either going to write 1 mole is equal to 6.02 times 10 to the 23rd if I'm dealing with particles, or I'll have 22.4 liters if I'm dealing with volume, or I'll have the mass on the periodic table if I'm dealing with mass. Okay. So this time I was given atoms, and atoms or particles go along with Avogadro's number, this 6.02 times 10 to the 23rd. And that would be equal to 1 mole of magnesium. Units cancel when they're the same. That's why we do this, so we can cancel out the units we don't want and convert to the units that we do want. We wanted moles of magnesium. That's what we have in our problem after performing this conversion. So we are ready to put it in our calculator and solve. The way these problems work is anything that is at the top, I would hit multiply before, and if it's at the bottom, I'd hit divide. So put the first number in your calculator, 3.01. That E right there in your calculator means times 10 to the 22nd. I see that the next number, ignoring ones, is at the bottom. So at the bottom means divide by 6.02 times 10 to the 23rd. Oops. Times 10 to the 23rd. And then I just hit enter, and the calculator returns this answer, 0.05. What we have to consider are significant figures. I take a look for the least number of significant figures in my problem. I see that I have 3 in this first one and 3 in Avogadro's number. That means that I have to have 3. If I use this number, 0.05, there's only one significant figure. You don't start counting them till you get to the first one from the left. That's not a 0. So this is the first one. So what I need to do to make sure that I have 3 is I just add 2 more zeros to the end. This gives me the same answer with enough significant figures, and I make sure and label it as moles of magnesium. Okay. Recap, they gave us atoms. We know that 6.02 times 10 to the 23rd atoms, if anything, is equal to 1 mole of that. We solved the problem and expressed it with the correct number of significant figures. Okay. Let's take a look at another example. This time, they want to know what the mass is. So what we're solving for is the mass. What we are given is 5 moles. So we always begin with what is given. We have 5 moles of, this is iron 3 oxide, commonly called rust. And we set up our problem so that we have the exact same unit at the bottom here. So I see that I have moles of iron 3 oxide. So my unit at the bottom is going to be moles iron 3 oxide. And opposite of that, we want to convert to mass, which is in grams, and we can see that we can always convert between moles and anything else. So I can convert from a mole to particles or particles back to a mole. I can't go directly between particles or volume or mass, but I can always go through a mole. So I see that I have 5 moles here. I know that 1 mole is equal to a certain number of grams. Okay. And if you remember from earlier, where do we find the molar mass? Well, we look on the periodic table. These numbers right here tell us the mass of 1 mole. Well, from the formula we can see that we actually have 2 irons here. So the way we want to figure out what this whole thing weighs is we have 2 iron atoms. Each iron atom is going to have a mass of 55 point, and I always round to 2 decimal places when I'm taking information off the periodic table. 0.845 rounds to 0.84 because of the fact that this is a 5. If a 5 is doing the rounding, that means that if the number before it is even, it stays the same. If it's odd, it goes up. So 5 is trying to round a 4, which is even, so it stays a 4. I also have 3 oxygen atoms. Each one of these, if we take a look at the digit we want to round to, is followed by a 9, so it's going to round 15.99 up to 16.00. So if I add these 2 up, I will get the mass of iron 3 oxide. So we can go ahead and do 2 times 55.84. Oops. And add that to my oxygen. And I see here that iron 3 oxide's formula mass is 159.68. So my mole units canceled, and I was left with grams of iron 3 oxide. It wanted to know the mass, which is grams, so I'm ready to solve this problem. Okay, this time I have a 5 at the top, and the next number is also at the top. If a number is at the top, it means to multiply it. 159.68. This is what the calculator sends back. We need to consider the significant figures. We see that we had one significant figure in the first number here, so we can only use one. 798 to just that first place, that first significant figure, is 800. So I would have 800, these are grams that we converted to, of the Fe2O3. And that would be our complete answer for this problem. Alright, this time we have a volume problem. Okay, so we want to know volume. That's our unknown. It's going to be in liters, and they give us 0.05 moles. So start with the given 0.05 moles neon. Remembering that we must always cancel out, so I have moles of neon. Moles of neon must go here, and I'm going to convert to liters of neon, and my conversion factor is 1 mole equals 22.4 liters. So 1 mole equals 22.4 liters. Cancel out the units that we don't need. We are left with liters of neon, which is what we were trying to solve for. So we just put this into our calculator, 0.05 times 22.4. And we are told 1.12. We only want one significant figure. 0.05 only has one significant figure in it, so we just round this to the first significant figure, so 1.1 gets rounded to 1. So this would be 1 liter of neon gas. And one more example. This one involves an extra step. Okay. Word problem: aspartame is an artificial sweetener. It's 160 times sweeter than sucrose. This is NutraSweet's active ingredient, and you can see they give us the formula here. And the question follows. It wants to know how many atoms. So when we're done, we will have atoms of nitrogen as our final unit. We have to start with 1.2 grams. Okay, so they're giving us how many grams of this whole compound that we have to start with, and they're asking us just to find the atoms of nitrogen. So we know how much of all this that we have. We just want to know how many atoms of this. So we're going to have to express this compound in terms of this eventually. So start with what's given. We have 1.2 grams of the aspartame. And we want to change this to moles first. We always have to go to moles in every step. So the units must match. I have grams of aspartame here. I need grams of aspartame here. Okay. So I see here that I have to go ahead and add the mass of this up on my calculator. Okay, so if you look on your periodic table, round into two places, you see that carbon is 12.01, and there are 14 carbons, plus I have 18 hydrogens that each have a mass of 1.01, plus I have 2 nitrogens that have a mass of 14.01, plus I also have 5 oxygens that have a mass of 16. So I use this mass 294.34. Okay, and that tells me that many grams of aspartame are equal to 1 mole of the aspartame. cancel out the unit that'll cancel. I'm now in 1 mole of aspartame. Okay. But the problem wasn't asking for atoms or molecules of aspartame. It was just asking about the nitrogen. So what I have to say at this step, once I'm in moles of the whole compound, is that 1 mole of the compound, the C14H18N2O5, well, every time I get one of these, I can see that I get 2 nitrogens with it. If I had 2 of these, I'd have 4. So every time I get one of these, 2 nitrogens come along with it. So 1 mole of this is equal to 2 moles of nitrogen. Now I am ready to continue my problem. Okay. I see that I've canceled my moles of aspartame, and now I'm in moles of nitrogen. Well, I want to figure out atoms. So I have 1 mole of nitrogen, and running out of room, I'll just put it up here. That's going to be equal to 6.02 times 10 to the 23rd atoms of my nitrogen. Okay. So I can cancel out the units here, and I'm ready to solve. I have converted from the grams by using the formula mass to moles of aspartame. I have said that in 1 mole of aspartame I can see that there are 2 moles of nitrogen there, and every 1 mole of nitrogen contains this many atoms. So putting this into my calculator, 1.2, next number is at the bottom means divide by 294.34. Okay. My next number is at the top, so that means times 2. And my next number is also at the top, so that's times 6.02 times 10 to the 23rd. And I get this answer back. I need to just take a look and see how many significant figures to use. Don't look at the number of moles within the problem when you're trying to figure out how many significant figures. All that matters is the grams that were given, the formula mass or Avogadro's number. Here I have 2 significant figures, so I'm going to round this number 4.90 to 2 significant figures. So I would write down 4.9, don't forget your power of 10, times 10 to the 21st. Of what? Well, they were asking for atoms of nitrogen, and that is what we converted to, so atoms of nitrogen. Okay. So the key to the success with these problems is just taking your time to look at the units that you have and always making sure that you are choosing units that match up so that you can cancel them along the way.